Hello everyone, welcome back to my channel, the IITian Coder. So in this video, let us see another problem, CodeChef September Long Challenge 2021, and the problem is basically January minimized digit sum. So this problem looks very easy. So like problem statement is very easy to understand. We are given f and b, and be the sum of digits of the integer n when written in base b, and we are given q queries consisting of three integers n, l, and r, and to find the value of b corresponding to which f and b is minimum for all b which are between l and r. So if there are multiple such values, we can print any of them. Now we need to find the value of b which will minimize the sum of the digits, right? So one thing you can do is brute force on the digits, that is like you iterate for b from all L to R, and for each of the B's you can actually construct what do you call uh, you can construct the representation in the base B and get the sum of digits, and whichever is minimum out of all you can just print that. So that will pass your second test case, but it will fail your first test case because you need to look at the constraints. So to do this, because you can see L and R are both 10 raised to 9, so either we need to do this in log n or a constant time. So that is the first hint for you, that you need to do this in log n or constant time. And there are q queries which are basically 10 raised to 3. So like there would be 10 raised to power 3 queries, each having separate n, l, and r integers. So let us brainstorm a bit. So original constraint, subtask 1, the problem is worth and is meant to be complementary. So basically there is a similar problem which is different. So let us take a look at if we can like arrive at some of the, what do you call, like we can arrive at some of the, yeah. So if we take 1, 2, 3, 4, 5, 6, 7, and so on. So these are basically our base values. So we cannot represent a number in base, like we can represent a number in base 1, but it's absolutely absurd. So the sum of digits would be n here, because like if we represent a number n in base 1, it is basically n only. Next is if we represent it in binary, so the sum would be basically all the powers of 2. So suppose we are given an n, so there would be powers of 2, right? 1, 1, 0, 0, 1, 1, 1. Suppose this is a number. So a sum would be basically 1, 2, 3, 5. So our answer would be 5 here. Just because if you represent, like this is basically I've given you the number in binary representation only. So it will be like wherever whichever power of 2 occurs in the final binary, your sum will have it. Now if let's skip 3 for now and let's focus on 4 to get an interesting observation. So if I take suppose 4, so note here that 4 is actually a power of 2. So when we do with 4, so suppose we convert the same number to what you call the force base representation. So this is 2 raised to 0, this is 2 raised to 1, this is 2 raised to 2, this is 2 raised to 3, this is 2 raised to 4, this is 2 raised to 5, and this is 2 raised to 6. So it will get converted to 4 would be here. So this will be 3, 2, 1, 0. This one basically gets transformed to here, that is to 4 raised to 3. This one will get transformed here, which is basically 2 raised to 2. This one, so 2 is transformed, basically 2 raised to 2 is 4 raised to 1. this gets transformed here, and this gets transformed here. So you can see the sum is 6, and this is 1, 5. Note here that 4 is a power of 2. So why did this happen? Yep, this happened because this one was coalesced here. So if this was the binary representation, we could just expand it here, 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 and extend this 3, 1, 1, which will give us 5. So decrement of. This gives us an interesting observation that we can start with a binary representation of a very large number, and like, let's suppose we can start with like n as an nth base representation. And so what we will have in the nth base representation would be, so suppose we are given a number n, uh, let's say we are given a number n, so what would its representation be in the base n? So it will be 1, 0, n to the power 1 and n to the power 0, right? This will be its representation in base n, and in base n plus 1 it would be 1, 1. Oh, sorry, in base n minus 1 it would be 1, 1, till, like, we are assuming here that we are not having 1 here still. Fine. So these are the two very simple, by simple, what do you call, these are very simple notations that we can start from. Now n will have some factors, which will be like, suppose say 2, 3, 5 are its factors. So what happens when you change the power, like, okay, so this is n base representation. Now what will happen, so this is basically n raised to 0, n raised to 1, n raised to 2, so on. Now I won't be sharing ahead of this in this video. I'll be making a video of the solution code soon, but these are all the hints that you can get from me. So notice here what happens if you try to change n with one of its factors. Just think about it. How does it actually change the digits, and how does it change the sum? So that's all we would be having in this video. If you like the video, please do like, share, and subscribe the channel. And if you feel this the hint was not relevant, or the hint was not to the point, think a lot about it, and when we come up with the solution, you will see how that the hint was relevant. So thank you very much.